now we're going to move on and continue our factoring, but we're going to approach things a little different. Back in Unit 8, we started doing perfect squares. So we're going to talk about some different words. In math, the word difference means what? Solution to a subtraction problem. Find the difference is, and what we're going to use here is difference of squares. Think about it, squares are always perfect. All four sides are always the same length, 90-degree angles, they're perfect squares. Excuse me. Throughout this lesson, I use PS to stand for perfect squares. So 9 is a perfect square, 16 is a perfect square, 25, 36, 49. These are some out of many perfect square numbers. We know that 9 is really 3 squared, 16 is 4 squared, 25 is 5 squared, 36 is 6 squared, etc. So perfect squares are those numbers in purple. I would like you to pause the video in just a minute. I'll do one example. But we did this in the last unit. It was the very last lesson, I believe. We are going to square that binomial. Remember, because it's a binomial, it really means x plus 4 times x plus 4. So what we have to do is we need to FOIL. X squared plus 4x plus 4x plus 16. That would get me x squared plus 8x plus, 16. All right, please pause the video and finish FOILing for me through the x plus 10, x minus 10. We'll compare answers in a moment. Thank you for pausing the video. Take a moment, compare your answers to mine. X squared plus 18x plus 81. X squared minus 10x plus 25. X squared minus 14x plus 49. And when we got to those special products, after combining the b terms, end at x squared minus 64. And on the last one, x squared minus 100. If you need to, take a minute, go back and look at my steps. I FOILed completely, showed all my work. If we have different answers, please see what we are doing differently. Okay, what we have created now is a perfect square minus a perfect square. Well, notice that is what I have right here. I have a perfect square minus a perfect square. Ooh, when I look back up here, I have a perfect square minus a perfect square. I do not have that here. I have a perfect square minus the b term plus a perfect square. I have a perfect square plus the b term plus a perfect square. What we're going to be working with today are factored forms that look similar to this, because notice there is no b term when I am multiplying opposite polynomials. So when I have a perfect square minus a perfect square, I'm going to take the square root of the a term. Remember, that's my a. So I would get x. I'll write it out a minute. minus the square root of the c term. B has been canceled out. There is no b term. So minus the square root of 169. That would leave me with x minus 13 times x plus 13. It doesn't matter if you put the plus 13 first and the minus 13 there. But if I was to FOIL this out, which I will do for you real quick, I would have x squared plus 13x minus 13x minus 169. Notice I created b's that disappear. So I would be left with a, which is x squared, minus c, which is 169. All right, so now as we begin to approach this, when you see a binomial, instead of thinking, can I make it simpler? Can I distribute backwards? I'm going to ask myself, is this a perfect square minus a perfect square? Ooh, yes. That's what I thought. I have a typo on my paper. Yours will be fixed. This is really 225. That is a perfect square I was aiming at. So when I ask myself, is this a perfect square? Yes. Minus a perfect square without a typo? Yes. The square root of the a term is x. Square root of the c term equals minus 15. And like I say, it doesn't matter if you write plus 15 first or minus 15 first. It really does not matter. Well, now I've added a little more to it. Excuse me. I see a binomial here. First, can we make it simpler? I don't know a number that goes into 49 and 9, so I'm still asking myself that simpler question. No, but it's a binomial, so I'm curious, is that a perfect square? Minus, is that a perfect square? Yes, those are my questions, and yes, they are. So I'll take the square root of the a term, so I need the square root of 49x squared, which is 7x. I will take the square root of the c term, which is the square root of 9y squared, to get 3y. This time, just to mix it up, because as I state, it does not matter if you put the plus 3y first or the minus 3y. On the last one there, can I make it simpler? Still ask yourself that. It makes your life easier. I cannot. I notice I have a binomial with a subtraction sign. So I am wondering, yikes, good thing I do this before I hand them out to you. Is this a perfect square? Is this a perfect square? And I think because I have to change it anyways, I'm just going to make that a 64 right now, because then we don't have two 49s in a row. My apologies for that. Okay, that is a perfect square, so I'm going to take the square root of 64x squared to get 8x. That is a perfect square, so I'm going to take the square root of 121 y squared, and I get 8x minus y, so 11y, and 8x plus 11y.